Okay, so we're going to look at a bit more advanced question involving gas law stoichiometry. For any type of question like this, one thing I like to do at the beginning is just to underline all the information that's given to us. So I'm going to just go through and underline all these quantities. So in this particular problem, I'm given some information about hydrogen gas, and I'm given some information about oxygen. I'm actually told that this is a synthesis reaction. And the whole purpose of this problem is to figure out how many moles of water are produced. So that means water must be a product. So one thing that can be pretty helpful is just to write down the chemical reaction itself. So I've got two reactants, hydrogen, which is diatomic, so it's going to be written as H2, and oxygen, which is also diatomic. And in the problem, they tell me, or they're asking me how much is produced, how much water is produced. So that means H2O is going to be a product. Now this needs to be balanced, so I'll put a 2 here and a 2 here. Now what I basically need to do is determine the number of moles of both of the reactants. And to do that, I'm going to use the ideal gas law, PV equals nRT. So I'm going to need to collect some information about both of the reactants. So I'll start with hydrogen, and then I'll also need to get some information on the oxygen. So I've got to have both of these in order to determine the number of moles of H2O produced. So let's start with hydrogen. So I'll just make a little list here. And see what variables I have. So pressure, I'm told, is 3 atmospheres. And volume, I'm given up here. So that's 5.45 liters. Number of moles, I do not know. That's what I'm trying to figure out. And then the R value, well, since I'm using atmospheres, I'll need to use an R value that agrees with that pressure unit. And that would be this one. And that would be labeled like this. And temperature. Now, I am given a temperature, but unfortunately it's in Celsius. So I'm going to have to convert it to Kelvin. So if you remember, to do that, you'll just take the Celsius temperature, which in this case is -10, and just add 273 to it. So that's 263 Kelvin. So I'm going to write that down. Remember that anytime you use the ideal gas law or any gas law, temperature has to be in Kelvin. It can't be in Celsius or Fahrenheit. Okay, so now I've collected information on the hydrogen. I'm going to do the exact same thing for the oxygen. And the pressure for the oxygen is 0.7 atmospheres. The volume, again, is given in the problem, 4.85 liters. N, that's what I'm solving for. R, it's going to be the same R value I used over here. And temperature, again, given to me in Celsius. We're going to have to switch that, make that Kelvin. So -150 plus 273. 123. Okay, so what I have to do next is basically use PV equals nRT to figure out the number of moles of both of these reactants. So let's see what we can do with that. Okay, so we'll start with the hydrogen here, and we'll just kind of extend this down. And we'll just run the calculation. So pressure is 3, volume is 5.45. We'll set that equal to the number of moles, which we do not know, so we'll leave that as N, times the R value, which is 0.820, oh, I'm sorry, it's actually 0.08206. And then the temperature is going to be From our chart up here, we saw that for hydrogen it was 263. Okay, so I'm going to solve for N. To do that, I'm going to take 3 times 5.45 and close that in parentheses and divide it by the other side, product of the other side, 0.8206 times 263. And as long as you're careful with your parentheses here, you can do this all in one step. So my answer, number of moles equals 0.758. So I rounded that 3 decimal places, and this will be our moles of H2. Okay, so now I'm going to do the same thing for the oxygen, and almost the same setup here with the ideal gas law. So pressure times volume. Set that equal to the number of moles times my R value times my temperature. And this time we'll plug this all in. So we'll have the product of 0.7 times 4.85 divided by the product of 0.08206 times 123. Okay, so this will give us the moles of the O2. There we go. So now we actually know the amounts of both of the reactants. So what we've got to do next is figure out how many moles of H2O we could produce with this amount of gas, and how many moles of H2O we could produce with this amount of gas. Whichever one of these two reactants makes the lowest amount, that's going to be the reactant that's known as a limiting reactant, and that will tell us the answer to the problem. So let's start with the hydrogen. We have 0.758 moles of H2, and we'll do a little mole ratio. Moles of H2 will go on bottom, and what we're solving for is moles of H2O. So anytime you have a mole ratio, which is a fraction where it's moles divided by moles, you're going to have to consult your chemical reaction. So if we look up here, H2O had a 2 in front of it, and H2 had a 2 in front of it. So that means when we fill in our mole ratio, it'll be 2 over 2. And obviously 2, if you multiply by 2 and divide by 2, it'll cancel out. So this will actually be the same number, 0.758 moles of H2O. So with this amount of H2, I can make this amount of H2O. Let's compare that to the amount of H2O that the O2 can make. So now we'll take that number, which was 0.336 moles of O2. And we'll do this of our mole ratio. Notice that this is almost identical to what we did on the other side, only this time I've got moles of O2 and moles of O2, and that I still have moles of H2O up here. Once again, we'll go up to our chemical reaction. You can see that the O2 has nothing in front of it, so that's going to be a 1 in our mole ratio, and the H2O again has a 2 in front of it. So we'll put a 2 and a 1. All we're going to have to do here is take this number and multiply it by 2. So we'll take 0.336 times 2, and we get 0.672 moles of H2O. Now remember, we said that we need to pick the lowest amount of moles produced. So when we compare these two numbers, we can see that this number is higher than this number. So that means that the O2 is the limiting reactant. So at the beginning of the problem, it asked us how many moles of water will be produced. And after all this mathematics, we found out that 0.672 moles of H2O could be produced.